Thank you so much for joining in. So in today's session, we are going to finish the module 4 revision. And to people who have joined us recently, the structure of these hackathons would be we are going to revise the concepts that are being covered by the primary faculty here, Professor Panduragan. Right? So let's proceed forward. In today's session, we're going to cover the balance of the module 4. And if at all you've attended yesterday's revision hackathon, we have covered what are transactions. We have examined the transaction, the block 5 lakh, and we have in detail understood how the few of the inputs and outputs are stacked out. Right. So today we'll go a little in detail about the data. Right. So let me share my screen. I'll also be sharing a few resources as well. Great. So how many of you finished the module 4 of Professor Pandurangan? If you finished this, if you finished the module 4 of Professor Pandurangan, type me in the chat box. Yes, thank you. So I would call user only. Great. Thanks, user. Yeah. So now let's proceed. First, let's go forward and see the block 5 lakh once again. Yeah. So now block 5 lakh we have. I'm going to share the link of the same here on chat. Yes. So in here, yesterday we have seen, how each block has multiple transactions and each of the transactions. Okay, so let me send it to everyone. Yeah. So each block has multiple transactions and how each of the transaction has more data in it and how inputs and outputs are stacked, right? So we have understood a little about the UTXOs where a person is trying to send some Bitcoin to another user, then how the process of the UTXO creation happens and how they are floating in the UTXO database on the blockchain network. So we've understood that. We've understood the structure of the transaction also. Now we'll also understand a little bit more about the transaction and how these inputs and outputs. Right now here we know that the value of Bitcoin is being sent and received, but how the processing happens, how the verification of that transaction happens, we'll understand more about that today, right? So now if we come here in our block 5 lakh, you can see that there are multiple transactions. I'm going to select this, the third transactions, meaning starting from 0, the third transaction. I'm opening it. And in that, you can see that, the time, the age of that particular block, and this, with the ID of that particular transaction in whole of the transaction in that particular block, right? In the 5 lakh block, this is the transaction at position 5 or the index, right? So all of these details are here. There are 2 inputs to it and there are 2 outputs, right? So we have understood that. But if we try to understand, because we are trying to go granular into the transaction, we are going to understand more about here in the JSON. If you click overview, you'll have the 2 inputs and 2 outputs. Now, if you go in detail, you can see that the whatever inputs, whatever you are able to see here in a graphical view are also present here and with an additional information as well, right? So now if you see here in inputs, there is something called the SIG script, which is nothing but the signing script. And there is also something called the PK script. And we'll try to understand more about these here, right? And this is where it is mentioned as input, right? And the six script also is there. So it is like a large bit string, hexadecimal string. Now, if we go and see the outputs, in the outputs, we have address, the PK script, and the value being sent and the transaction ID, right? So we are going to go forward from here and understand more detail about it, right? So because we have two outputs, it has the two sets of these. Similarly, for inputs also, we have two sets of these inputs, right? So to understand a little bit more about it, every output that has, it has something called OPDUP. So to understand, now we are trying to get this data from the blockchain.com's explorer. Even you can use many other explorers also. So one such link I'm going to share here, which will have a different kind of a transaction, which will have a detailed transaction layout also, right? Let me share the link here on chat. Great. So of the same, I'm sharing here. Yes, Sujman, should not be a problem. You'll have the lecture on the inner circle. You can go ahead. Even in the mail, you'll be having the mail that you received, and that the link to the YouTube restream, you'll be able to access from there. Should not be a problem, madam. Thank you so much. Great. So now, if you see this another explorer that we are using. So basically, these explorers are going to provide the same information. So how you can instead of the blockchain explorer, you can even open this. Similarly, type 5 lakh and see that the Bitcoin, the block 5 lakh is there. So you can see here more details. Okay, so you might be confused, like it says the mine date is December 18th, and here the mine date was December 19th. So it is only because of the time zone. So do not worry about that. So now you can see the all data is similar here also, right? So the transaction count is 2701, and all of this is as intact, right? So now if at all we want to go more in technical details, you can see that each of the transaction has the same, each of that transaction, that block is listed here. I'm going in the same transaction I have opened here on the other website, the blockchain.com explorer, right? So the only reason we are using the other one is to see this additional information. So we'll be able to see this additional information here, right? Now you can see that here all of the details, the sender detail, and all of these are mentioned. Now let me share the same link with you so that you'll be able to check it. Okay, so is my screen visible? Okay, so should I mention it? Yeah, thanks. Let me share my screen here. Great. So I hope you should be able to see my screen now. Right. So now in here, the block chair also, you'll be able to see the same details. Right. So I have just shown here, when you come to this website, the link that I've shared, you can still enter the same 5 lakh block and see more details here. Right. So I'm going to click and see that the same details are also mentioned here. When just maybe the time zone could be different. So that is the reason the time mined here, it says December 19th, and here it says December 18th. But the rest of all of the information, like the transactions included in the block, are also same, right? So you can open the same blocks of transaction and see more data. So why are we using the another link here is because we wanted more additional data. So one such data is here. Now, when I open any transaction here, right? So when I'm trying to open any particular transaction here, you can see that it has something called this script, show script. Now, I'm going to copy this and also put it up here for ease of viewing. So every output that goes out, this is the structure of the output. Now, let me make it easy. Okay, so now if you see this particular structure, every output that is going here will have a specific structure, right? So in that, these OP DUP, OP underscore hash 160, and then there will be a 20 byte public key, then OP underscore equal verify, and then OP underscore check sig, right? So you can see this will be the structure that is common for all the transactions, right? So when you're seeing details of it here, you might not be able to see these OP DUP and all. So these are called script commands, right? So we'll see more about the script commands here. So now to understand how blockchain network verifies each of the transaction. So the blockchain network uses its own very simple language. The name of the language itself is script, right? So in that script, there are some commands like this OPDUP, OP underscore hash 160, equal verify, and checksig. I'm going to share a resource where there are more commands also. But this particular script language is only useful for doing a limited scope of work. You would not be able to do some engineering, you'll not be able to solve some engineering problem. It is only there to verify the transactions that are coming through. Okay, so we'll try to understand that in a detailed way here. So let me bring up this particular resource. So what is this script? Okay, so I'm sharing the link of the resource also here. You can copy and save it for future reference. Now, script, Bitcoin uses a scripting system for transactions. The name of that is script, right? So now you can see that there are a lot of commands in that, right? So there are like OPDUP, the one that we are talking. With what it does, there is a description of it. It duplicates the item, right? So we'll understand what each of these four particular commands do, right? So we are going to understand about that. So now what we have understood is we have understood the language that the whole Bitcoin system uses is to verify the transactions validity and the ownership, all of that. It is called script and it has a specific set of commands, right? So in that commands, we are going to in detail, a little detail, we'll see these four commands, and then we'll see how this is helpful in checking the signature that is being sent by a sender and how the ownership is validated at the receiver end. So we are going to see a little about that. Now, in this particular script, you can in detail go about all of them. So like we have OPDUP, similarly, we have OP hash 160. Now, OP underscore hash 160, what it does, whatever input is there, it is hashed twice. First with SHA-256 and then with RIP-EMD 160. If you remember something that we did while we are generating the Bitcoin wallet address, right? So hash 160, OP underscore hash 160 is going to hash it twice. And similarly, OP underscore equal verify, what it is going to do is, let me just, so it's going to verify. It's going to just going to verify. So it says same as OP equal, but also runs OP verify. So what is OP equal? Returns 1 if the inputs are exactly equal. So it is going to match the inputs and then it's going to verify, right? If both of them are same or not, right? So that is the another. Then we have this OP check sig. So how we have extracted this? We have extracted this from the transaction history only. So every output will have the same structure, right? So we're trying to decode each of these commands, what they do, right? So now what OP underscore check sig does, so the entire transactions outputs, inputs and the script are hashed. The signature used by OP underscore check sig must be valid signature for this hash and public key. So basically whatever public key is being sent and the hash of that has to match, right? So it is going to check the signature of that particular public key, right? So now let me just decode. This is what Professor Pandurangan sir writes in his lectures, which is the command looks like this. There is signature, then there is public key, then the OPDUP hash 160, then there is equal verify, and then there is check sig, right? So these are all script commands, and the language used here is script, right? So, and we have seen that inputs, whatever outputs that are there, that are having this structure here. So this structure here is OPDUP, OP hash, the 20 bytes of public key, OP underscore equal verify, OP check sig. So this is what is there in the output along with all the other values that are there, right? So how you can see that? You can see that here a little in detail. In overview, you can see these IDs. And here also you can click on this transcription scripts, right? So if at all you do not want to go here into the JSON, you can click here. Here, if you see this, there is this copy, and then there is this transaction scripts. You can click here to see that OPDUP, OP hash, and there is this 20 byte public key, equal verify, check sig. Then there is signature script. This is passed with every transaction, right? So we'll go in detail about it. But if you understood this structure of every output, if you understood that, type U in the chat box, right? So what we have done, we have gone to the blockchain 5 lakh. In that, we have opened one transaction. In that, we are seeing the transaction script here, right? So if you understood the structure of every transaction, type U in the chat box. People who are watching this on our social channels, you can use the chat to type and interact. Thanks, Shashank. Thanks, Ashish. Great. So now what is the name for this? This is called the PK script, right? So the whole the structure that we are talking about here is called the public key script or the script public key, right? So the output structure, let's say PK script. Okay. So now we have understood what is PK script, right? So the structure of it along with the real life example of it, right? So it also passes the signature script also. Yeah. So user asks, is it the locking script? So we'll go in detail about the locking script also, sir. I'm also going to share with you the reference for that. So right now it is the PK script. It is the public key script. So the locking script will come as we go forward. So yeah, thanks for the question. Now, similarly, on the two side of it also, you can see the same PK script, right? That is what we have understood, right? Now let us try to understand what each of these are trying to do, right? So we'll also understand a little more about stack, right? Great. Okay. So the link to that. Okay. So Prasad sir, user. Okay, your name is coming as Prasad. So Prasad sir, your name is coming as you. So you can rename yourself. Okay. So thanks for that. Yeah. So correct. So this, while we are verifying, will because this is helping us to set out the output. You can consider this as the locking script, right? So let me share this particular link here. Let me know if my screen is visible. Okay, so this is another reference which will help us understand a little more about this stack, right? So what professor explains us is that all of this, because the script is a very simple language, you'll not be able to do something out of the blockchain network, some assembly language or microprocessor language. You'll not be able to solve engineering problems. It will help you solve the blockchain related commands, which are the script commands. Now so what this script does is, whenever the script command gets executed, it all these inputs, whatever are there, which is the signature, the public key, and the command op underscore dup hash 160, all of this is taken out from the stack, something called stack. You can consider as the memory space where it is using to perform this operation, right? So what the script command does is, it takes inputs from the stack, verifies it, and puts it back onto the stack, right? So let us try to understand more about the stack. So what we have understood till now is, we have understood about the PK script, the structure of the output, which has the public key along with the other script commands, right? And then we have understood about the script, what is the script language, and what is the scope of it. We have understood that. Now let us try to understand about stack a little, right? So now if you see, go forward in this reference that I've shared on chat as well. Now here there is a very good diagrammatic view. Now what stack does is, in the first step, whenever there is an operation that is happening, it will load. For example, this is the operation ABC. It will load each of it step by step, and then it will give out the output, right? So if you have worked with programming languages like C and all, now this is stack goes in like the all of it is stacked out and popped out, right? So this is what we have understood about stack. We'll try to understand more in detail about the same, right? So now if you see our example, now what we are trying to do, we are trying to put first signature, the public key, and the check sig, whatever command is there, it is going to check if the public key and the signature are of the same person, right? So then only the UTXO, whatever amount that the person is sending, uh, the ownership is proved and is received by the recipient, right? So the check sig is the command. If you have seen what we have done here, we have tried to understand here what is check sig. It is going to check if the signature and the public key are matching, right? So if you see this particular example, what is happening on the stack is, the command what is being performed in the first step, you can see that the signature along with the public key and check key, both of them are first taken out in the stack, then checksig will perform if they are going to match or not, right? So this is how the operation happens in the stack. Yes, Prasad sir asked what is the difference between secret and secret key, a signature and secret key. So basically, the secret key is with that particular person, sir. If you have seen of our previous hackathons, let me just bring up that slide so it becomes easier. So it's a very simple one, sir. Now, signature is something, yeah. So if you see this particular example here, the difference between signature and the secret key. So now there is a signing algorithm. The signing algorithm takes the agreement and the secret key. So basically, secret key of that particular person is an input to the signing algorithm, and that whole of it produces a signature, right? So signature consists of the message along with the secret key of the signer. So I hope this clarifies here, Prasad sir. Correct. Message plus secret key, I would not say like plus. These are inputs to the function, the signing algorithm. Then, the signing algorithm does the logic of signing, right? It does internally the hashing and everything. Correct. Yeah. So the hash of the message plus secret key plus, it is not plus, I mean, maybe you are meaning the same thing. When you say hash of m plus secret key is signature, it is not plus, it is basically these are inputs to the function, and the the operation, the signing is happening within, and then the signature is the output, right? So I hope you've got it, sir, because you can yes, thank you so much. Now let's come back to our today's session. Thanks for bringing that up, sir, so it always clarifies. Yeah. Now, if we are on our resource, right? So here, what we are doing, we are stacking the commands along with the inputs. Now, signature is an input, public key is an input, and checksig is the command, which is going to check if both of them match, right? So that is what is happening here. Now we'll try to see in detail the whole command altogether, right? So now first, in the first step, we understood about this stack. In this second step, we have understood what checksig does. Now here we have understood OPDUP, right? We have understood OPDUP from here. The whole of whole of the commands, we have understood OP underscore hash 160, OP underscore equal verify, right? So the link to this also is there on the chat. So people who would be watching this on Teachable, you can see that this will be there in the resources as well, right? Okay. So now if we come here in detail, what is happening? First, the stack is empty. When in that first, what we are doing, the signature and the public key is there. So first, the signature is stacked along with the public key. Then there is this the command OPDUP. It is going to do duplicate. Okay. So let me try to convert this into a image format, so becomes easy for you. It is moving very fast. Just give me a moment. I hope this works. Yeah. Not work as intended. Okay, so let me take screenshots of the same and put it here. Great. Let me share my screen back again. Okay, hope you are able to see my screen now. Great. So in here, you can see that in the step one, what is happening? The stack is empty. And what we have here is the script sig, the signature script or sig script, both are same. Now sig script and which has the signature and public key in it, right? Now, what are our commands? We have the operation. OP is nothing but operation. We have duplicate operation, hash 160, equal verify operation, then check sig, and we also have the public keys hash, right? So now, sorry, we are going to, the next step in this stack, we have stacked the signature and public key, right? So now then the operation is being performed. So what duplicate does is it is going to duplicate the public key, right? So when it, because we do not want to work on the original, we want to work on the duplicate. So here it is going to duplicate that command now has performed its operation and duplicated the public key, right? Now then we'll perform the hash 160. Now what we are doing, the hash 160, this is also put up operated on the public key. Now public key and the hash 160 generated the public key hash, right? So now we have the public key hash. Now after that we have the next command, which is the equal verify. So now equal verify is going to do is it is going to take the public key hash that has come as with the input, right? And verify the public key hash that was there, that got generated, but the hash of that public key, what is coming in the signature script, if both of these are same. So the equal verify is going to verify if both of the hash are same. And when both of these are same, finally the check sig is going to check, match it with the signature. Okay, I think that we have missed that particular screenshot, right? So final one. Great. So now the check sig is going to do the final check, right? So if my screen is still visible, is my screen visible? Yeah. So if my screen is visible, what check sig is doing, it is verifying the public key that is there, that was that the duplicate, before duplication, whatever the original is there, and the signature are both matching or not, right? So what we have done from the beginning, we have the stack empty, the signature script, and the signature, the public, the commands, the duplicate hash 160 commands that are coming up in the output, right? So the output, along with that, there is the public key hash is also there, right? So if you remember the OP, the output that I've seen, the public key script, the PK script, you remember, and the signature script that is also coming along, right? So now these commands are one by one getting executed. Now both of these are getting added to the stack, then duplication is happening, then hashing is happening, then equal verify is verifying if the hash that was in the OP public key script, the hash and along the signature scripts hash, both are same. So it verified. Okay, if it is verified, then finally the check sig is doing okay. So both of these public key and signature are matching, and then hence the ownership is proven or this transaction is valid, right? So how many of you understood this particular all these steps here, right? If you understood this, type U in the chat box. Okay, thank you so much, Rayo. Signature is MPK. You Prasad sir has another question. We also have a question from Ganesh sir. Right? Okay, so Ganesh sir, not a problem. You can catch it up from the inner circle wall. Should not be a problem. Looking forward. Yeah. So now we have Prasad sir question. Signature is M, the public script. Signature is M comma public script. So how can it be equal to public script? Okay. So okay. Okay, Yasir sir, thanks for joining in. So if you've recently joined, so let me just share the structure of this particular hackathon. Now, Yasir sir, if you go through your Teachable, right, there are all the lectures that are there. The revision hackathons are nothing but a revision of whatever Professor Pandurangan sir has explained, right? So these all the recordings of these are also going to be there within the inner circle vault. These happen in a cyclic fashion. So you can see the recorded sessions of Professor Pandurangan, where in detail everything is explained. And you can also join the live classes. Now we are in the module 4. Now we are covering the module 4. So we started from module 1 and we are now at module 4. So like this, you can even attend the live sessions where we are going to revise whatever Professor Pandurangan sir has mentioned, right? And also if there's any question that comes up, we'll take it up here. And if there is anything that needs more inputs, we'll stack it up for our upcoming sessions. Okay. Yeah, so you can go ahead, watch the actual lectures by Professor, or you can also, go through the revision hackathons. I'd request you to first go through the Professor Pandurangan sir's lectures in the particular sequence. So let me point you in that particular direction. Please. Right. So let me share my screen. Great. So if you are able to see my screen, this is how your Teachable will look like. In this Teachable, you can go complete these lectures. Now we are revising the module 4, this particular lecture, right? So if you go through it, you will find the same contents, right? So here we try to bring up more resources and make it easier. Yes. Thank you so much, sir. Yeah, so now Prasad sir, Sagar, I think this instruction also applies to you. You can continue the start going through professor's modules, or you can in your inner circle also you can see the revision hackathons. You can watch maybe the professor's lecture along with the hackathon both to strengthen the concept. Okay. Yes. Thank you, Yasir sir. Thank you. Now, Prasad sir, yeah, signature is hash of M and public key. So how can it be equal to public key? Okay, so it is not matching the public key, sir. Okay, so let me bring the slides. Let me share my screen once again. Yeah. So Prasad sir's question is, because signature is is the output of the hash of M along with the public key. So how can it be equal to public key? So it is not equal, right? So here we are not doing the equal verify there, right? We are doing the check signature function there. right? So first in this particular stack, first there are two things, the PK script and the signature script. In that stack, first, the public key. Okay, so the public key and signature are stacked in. Then all the operations are executed. First, the duplicate operation. Now the duplication is happening of the public key. Okay, then hash 160, then the hash got created, and there is also a hash that came in the public key script, PK script. If you remember, OPDUP, OP hash, and there is a 20-byte hash, right? So there is also a hash of it, right? So that is also now put into the stack, right? And equal verify, yes, hexadigits. Now equal verify verifies the hash, right? And what checksig does, checksig command does checking of the public key and signature. We are not running equal verify on public key and signature. We are running the checksig. Now, Professor Pandurangan sir also explains in the lecture, checksig is nothing but your, elliptic curve. Because we've understood about the elliptic curve, the checksig is nothing but the verification algorithm. Yes, correct. ECDSA. So there, in that, within that particular command, it is by default using the elliptic curve and then doing the verification. So I hope your query is clear right now, sir. Right, so we do not run the equal verify, we run the checksig. Okay, thank you so much, sir. It also helps to make it simpler for others as well. Right. So I'm going to now go through the whole video or the GIF once again. Yeah, we are here. Great. Now, sorry, here, if you see this particular reference link that I have shared, the link to the reference will also be there in your Teachable. Now, you can see here what is happening step by step, right? So stack is empty, public signature and public key get stacked. Then each of the operation, duplication is happening. Then hashing is happening. Then the public key hash that got generated and the one that came with an input are equal verified. And then checksig checks the public key and the signature. Yes, sir. So Prasad sir, maybe if you're on desktop, maybe you wish to share the screen. Let me. Yeah, or you can let me know what is the question. Unmute and you can ask, because I have been through professor's lecture and maybe I'll be able to, guide you there.
So there's a portion where professor says.
Yes, yes, sir.
SIG on TCA, that is, he's assuming an input transaction from C to A. Then PK. Then he says this is from input of transaction A to B. Okay, yes. Because they refer to that basic transaction from where he has got something. Correct, A has got from C. Then there's OP DOP, OP hash 160. Then that is that 40 hexadigits, and OP equal verify, OP checksig. This part is from output of TCA.
Okay, I think I've got your question, sir. So let me share my screen back again.
Okay.
10,000 nodes across the world. Yeah, so I got what you're referring to. Let me share my screen here. Okay. Let me share my screen here. So here in professor's lecture, you are referring to this portion where he is talking about from C to A, or the other person X to A, an input. Am I right, sir? Prasad sir, this is what you're referring to?
Yes, there's one portion where, maybe scroll below, they'll say one portion has come from the output, one from the input. After the stack and all that.
Yeah, here. Yeah, so basically, this is what we have discussed, sir. Maybe you can simplify it. So here, the stacking, if you see the stacking here, it will be difficult for me to explain here, and that is the reason I have used the image.
Hmm.
So you understood the
No,
stacking.
that stacking I understood.
Yeah. So now here, what sir is trying to tell here is now whatever input, for example, A is sending to B, right? So now A is sending as in the output of A is going as the input for B. So how the output for A has come, like how the input for A has come. He
That
said,
he refers to the index of the input from C to A, that index which pertains to A.
correct. So that is what he's trying to explain here, sir. So only thing is I was.
No, this part there's some further down. I think he gives that particular input and output from TAB and TCA.
Okay.
So I was wanting to know whether the full sequence is that entire sequence starting with SIG on TCA, PK, OP DUP, OP hash 160, OP equal verify, OP check SIG. This entire thing, he says first two are from input of TAB, the others from output of TCA. Now this forms the entire transaction.
Okay, so I think the confusion is arising because there are the two transactions sir is verifying T to T, T and T hash. So first understand transaction structure is simple. He was trying to answer one question coming from the query. How is the output? Like C is the person.
Yeah, that I understand.
Yeah, so that also you have understood, that is clear. If you're a little confused about how the PK script is there for each transaction. So what a transaction consists of. Now that is where we go live here in the transactions. Now each of the blockchain transaction. Now here we are talking about the block 5 lakh. You can even navigate on your system. So we are opening once any of the transactions. Out of that transaction, so you can see that here this transaction, the scripts for that transaction are mentioned, right? So each of the transaction will have this, right? So now you see from it is this particular ID, and the scripts for that have the same OPDUP hash and then 20 byte public key along with the signing script. Now, when you come on the other, the two also, here the signing script is not there, but you can see that there is the public key hash, the public key script is all there. So a transaction, he talks about something serialization. A transaction has got a lot of details, right? So each of the transaction, like for example, in this transaction has got a lot of details where only where each of the input consists of these and each of the output consists of these. So this is what he explains here. So input consists of the signature script along with the PK script, and the output consists of the transaction ID and the other address and all other details, right? So this is the whole transaction. The whole transaction is this. In that there are multiple inputs and multiple outputs. Not each output signifies a transaction. The whole transaction has multiple inputs and outputs. The structure of inputs and outputs is being discussed here, sir, right? So I think I understood your query. What you mean here is the output, what we are talking about, the PK script is same as the transaction? My answer to that would be no. Transaction consists of inputs and outputs, and input and output structure we have discussed now. Yeah. So if you have understood the stacking portion and all, that should be good. So you asked another question. Yeah. So is this portion clear, sir? As we proceed forward, this will even further become clearer. But if you're able to understand. Yeah. So what I feel, yes, sir, you can go through this once again as well. Should not be a problem. But I feel that you already got all the concepts, the stacking, the script command and everything. So I think you're good there. Yeah. So this is what we have discussed till now. We have discussed about the transaction script, the script commands and everything. Now we have also understood the stack, how everything is tagged and how all of this is verified. Now that we have understood all this, so we are approaching the conclusion of our today's hackathon. Let me, before that, share with you one of the reference. If this will be useful, let me just check that. Yeah, so if we remember yesterday, Vasu sir, you asked about the UTXOs. Maybe this reference is going to help, right? Yeah, so this particular reference that I'm sharing here will clarify more about UTXOs. So basically, whenever a transaction is happening, whenever a transaction is getting uploaded onto a blockchain, there is, for example, here the person Joey is like, there's a lot of transactions that are stacked. Out of that, we are looking at this transaction. Now the person Joey, he is sending some blockchain to so some Bitcoin to Alice, right? So now this is the first transaction. This is the first transaction that is happening here. And later, if Alice is trying to send something to Bob, right? So what is happening? You can see that green here is the UTXO and red is the spent, right? So now when Joey sent some Bitcoin to Alice, first the UTXO got created, and when Alice sent it to Bob, that got converted into a spent transaction output, right? So in this transaction 2, you can see that there are two UTXOs, one back to Alice and one to Bob, have been created. So this is like a repetition of our previous lecture, but little on a visual format. Now, similarly, if Bob is trying to send it to another person in transaction 3 to Gopesh. So first, in this transaction here, the Alice's is unspent because it is with her. Now, Bob is spending it. That UTXO got removed or disqualified from the system, and then two new UTXOs got created, Gopesh and Bob, and this is how it goes on, right? So this particular reference will also be helpful as if at all you want to understand more about UTXOs as well, right? So the same here has been mentioned, the Joey sent and the UTXO of towards Alice and Joey got created, and similarly the block keeps on getting added. Great. So this marks a conclusion of our module 4, the revision hackathon. And if there is any other query that is coming in, you can type, let us know in chat or unmute and ask. If you are clear with the whole module 4, if you remember the whole of the module 4, we started from the elliptical curve, understanding more about it, and then we got into understanding the UTXOs, and then today we have understood more in detail about the transaction. Yesterday we also discussed the transaction fees and everything, and today we have understood the script, the signature commands, so the script commands and how the signature verification is happening. Yes. Okay. So I hope today's lecture was clear. If you have understood and the most of the hackathon, or if you have revised concepts from the actual hackathon, you can type U in the chat box. Thank you, Prasad sir. Thank you, Sharayu. Great. So yeah, so one of the questions, maybe Suju ma'am is not here, but one of the questions regarding the Genesis block of yesterday. Let me try to share another reference here. I'll also share my screen. So this is very interesting that, Suju ma'am, you've asked. If there's any further query, if you go through the recording or anything, you can let us know. So basically, we'll come across this more. And here, when you look at this, Genesis block is the first block that got created way back on 3rd of Jan 2019. We have also seen details about that here on the Bitcoin Explorer, right? So we have seen, let me also bring it up. We recheck. Maybe I can use another Explorer. Sorry. Is my screen visible? Okay, so maybe the search is not. Yeah, I've got it. Great, thank you, Sharai. So, Yasir sir, what you can do is go forward and continue watching from the beginning on the hackathon, so module 0, the orientation, and you can continue slowly come catch up with block, our revision hackathons. Should not be a problem. Yeah. Okay. So maybe no worries, but I'll also share the link for the Genesis. Thank you so much. Yes. So you can always, you can always join in any of the hackathons and ask queries that you come across. Not a problem, right? So the recordings of the same will also be there, so you can watch the lecture in combination with the hackathon also. So now the Genesis block is the block 0 or block 1, and yesterday we have seen this on the Explorer also. I'll also map that reference. And when this block was broadcasted, the question yesterday was, what was the transaction fees and who sent it? Like, all that details, because all of the other blocks, preceding blocks, will have, a transaction input and output, but Genesis will not have the input because that is the first block, right? So even it has its own hash, and there was 50 Bitcoin reward that was sent to the Genesis block, and this particular reward, and this was a hard coded block, right? So that is the reason you can see that the logic of it, a little of the information we do not have in clear, right? So it is unknown as to whether the Genesis block's reward was intentionally unsuspendable, as there was no explanation regarding this from Satoshi Nakamoto, right? So there were a few details because that was the Genesis block. It kind of was hard coded because there is no previous block to reference. Genesis blocks are generally hard coded into the software. So whatever input came in, so they have passed it on without actually going through the whole verification transaction mechanism and everything, right? So the hidden message that was there in the Genesis block, which we all know, in module 0 or 1 also sir covers the times 3rd Jan 2009, Chancellor on brink of second bailout for banks. This message was there, which shows the strong relevance to the reason behind Bitcoin, right? So all of that information is there, and more information on this will go as we go further. But that is the reason we are not able to find more transaction information, because most of it was hard coded, because that was the first block, right? Okay, so now this block was opened. Now you can see the age of that particular block. 14 years from now, it was there, and all of the other details, like the major question came in when the fees and the inputs and outputs were 1. The input value was 0 and the output value was 50 Bitcoin. So how did this came in? So this was actually pre-coded. Great. So I hope that answers. I'll also share this reference also in the links on Teachable. Great. So I hope if there's any other query, you can put it on the chat box. else will meet again on Wednesday. Yeah, so Sagar, let me just show you on Teachable. Now, when you go to your school.pixeltest.com, you will be able to see this. All right, so let me show it to you. Right now, this is how the lecture will be visible to you, Sagar. And you can click on start of this. When you click on start of it, it will start from the beginning, right? So first you'll finish module 0, then you finish as in you'll finish the orientation here, complete and continue. Then you will finish the next lecture. You can choose to watch it here or on, because it's unlisted. You can watch it there. Great. So yeah, so this you will be able to find it. There's another portion that's called inner circle. You can go in inner circle towards the end. You'll be able to find it, sir. So as you'll have inner circle, the interview mastery, your actual course, and the orientation. You can see it in inner circles. Great. So today's lecture will be uploaded post when it. Yeah. Great. And Ashish. Yes, Ashish. I hope I mean your question is not clear. Okay, Sagar has other questions. Sagar, can you paste the question if there is anything? Yeah. Yes, so Sagar asked, as we are revising module 4, means next week module 5 revision will be there. So can I get detailed revision plan schedule so that I can plan it in my schedule? Sure, Sagar sir. So I the email. So to be clear, normally coming from next week, every revision hackathon, each week there will be 2 revision hackathons. From next week, it will be Monday. So it will be Tuesday and Thursday, right? Every Tuesday and Thursday, we are going to revise concepts about blockchain, right? So that is how you can plan. So it is very fixed in nature, like Tuesdays and Thursdays, blockchain hackathon at 4 o'clock, right? So you can plan it that way. I can also share with you a detailed schedule as well, right? So on people who are in the AI or blockchain world, for the AI hackathons happen on the other days of the week. Yeah. So apart from Tuesdays and Thursdays, the other days we do the AI hackathons: Wednesday, Friday, and Saturday. Okay, so you're already part of the blockchain community, but if you're talking about the AI, the blockchain space, so I'd request, I'd personally share. So can you confirm your email ID once, Sagar? So I'll be able to share with you. You can confirm on chat. Great. Yeah. Yes, sir. Joined on Jan 2023. Yes. So you might have received the email also, but let me share the link to our blockchain space. This is on the Mighty Networks. Let me share my screen. Yes. So I hope now I understood. You're asking about the blockchain space, the community on here, right? So basically, I am sharing with you the link to the blockchain space. Here you can join in and interact. Yes, yes, great. So let me share that invite link here with you. Yeah, so I have personal the link for the community. People who have not joined, you can go through your email and join it. And Sagar sir, please open that link in a new tabs. So it will, because it will be flashed out once we end the session. So yeah, so I hope I have answered your question, Sagar sir. Great. Okay. Yes. Thank you so much. Thanks, everyone. Thanks for joining here. And today's session is shorter than regular, but we have completed whole of the module 4. I request you to even go through, the module 4 by Professor Pandurangan. Maybe if you have completed it all throughout, maybe you can watch it in a faster pace as well. Great. Thank you so much, Sagar, for that. Thanks everyone. And looking forward, we'll meet again on Monday. The schedule, the links, the details will be shared over email. Sorry, we'll be meeting on Tuesdays and Thursdays. Great. Thanks everyone. See you in the next hackathon. Thank you, Jay Ganesh sir.